Number 11, the reaction of hydrogen peroxide going to water and oxygen is first order. All right, so that's important, first order. All right, in hydrogen peroxide, and under certain conditions has a rate constant of 0.00752 at 20 degrees Celsius. A reaction vessel contains 150 milliliters of 30% hydrogen peroxide by mass solution, and it gives you the density of that solution is 1.11 grams per milliliter. Gaseous oxygen is collected over water at 20 degrees Celsius as it forms. What volume O2 forms in 85 seconds at a barometric pressure of 0.977 atmosphere? The vapor pressure of the water is 0.23 atmospheres at that temperature. All right. Well, first order. All right. Now we're looking for concentrations. We got time and we got K, so I'm going to say that we have concentration H2O2, hydrogen peroxide at time T, equals concentration of H2O2 at time 0, e to negative KT. All right. So I need to get the concentration, or we need to get the concentration of hydrogen peroxide. What do we know? Well, we've an amount. We have 150.0 milliliters of solution. All right, and we know density-wise, it's 30%. All right, not 30%. It's 1.11 grams. So 1 milliliter of solution is 1.11 grams of solution. All right, and then we know that for this 30%, we have 30.0 grams of H2O2 per 100 grams of solution. So we got 100 grams of solution, 30.0 grams of hydrogen peroxide. All right. And then we know, right, we have, well, let's go with this. 2 times 1.01 plus 2 times 16, right? That would be 3402 is 1 mole. All right. And that gives us 1.47 moles of H2O2. And our volume is 150 milliliters, which is 0.1500 liters. So it gives us a concentration of 9.80. All right, so now we can come in here. Concentration of hydrogen peroxide at time T equals 9.8 molar. Times e to the negative. K is 0.00752 seconds negative 1. And T is 85.0 seconds. So it means our concentration of hydrogen peroxide at time T is 5.17 molar. All right. Okay, so we know what is at the end. So how much reacts? We start with the 9.80 molar, and we end up with 5.17 molar. So that means it looks like 4.63 molar reacts. All right. Now, if we have our 1 150 or 0.150 liters. And we know that in 1 liter there are 4.63 moles of H2O2. That means we got 0.695. All right. So if we take our 0.695 moles of H2O2, moles H2O2 here, moles O2 here, and if we look at our balanced chemical equation, it's 2 hydrogen peroxide to 1 O2. So that means we're going to have 0.347 moles O2 formed. Okay, so if that's the case, we can now use PV equals nRT. But now the pressure, right? The pressure, the atmosphere, right, is 0.977. However, the H2O vapor, right, is 0.023 atmospheres. So we have, this is the pressure of H2O vapor, and this is the pressure of the atmosphere. All right, so how this kind of works, just very simple apparatus, let's just say. You had a container, and in this container, you have a tube. And this tube comes up something like this. And it's inside your liquid. And let's just say somehow it's kind of sealed. Somehow it's either sealed up here or whatnot. Okay, so that all the gas, all right, all the gas is going to go up. And so you're going to have this tube here. So you have H2O2 and H2O, right? And up here, we're going to have O2 now. However, because this is water, you're also going to have H2O up there, right? For vapor pressure. And so that vapor pressure is going to be there. And we just got to measure the pressure. We can't measure like what's just oxygen. We measure the total pressure, right? And so this is done so that this water here is actually full. So it's completely full of water, right? So that's all full of water when we put the tube in, invert the tube. Completely full. We can do it. We do it in actually our seated Chem 1 lab. Something very similar to this. And so once the hydrogen peroxide reacts, all the bubbles come up here and all that oxygen's up here. But because water is water, a certain amount's going to evaporate, and it's that much at this temperature. I mean, so that means the observed pressure would be the difference here, right, which is 0.954. Right? So the atmosphere was what? O2 and H2O, right? This is O2 and H2O. The vapor is just the H2O. All right, so now we can solve for V, right? V equals nRT over P. So N, we found out we have 0.347 moles of O2. We know R is R, 0.08206 liters atmospheres, moles Kelvin. Temperature, all right, it was 20.0 degrees Celsius, right? Which 273.15, 20, right, 0.0. So that's going to be 293.2 Kelvin. And then our pressure was 0.954 atmospheres. So that means our volume is going to be 8.75 liters of O2. Wow. So let's recap real quick. First order kinetics, we had to first figure out how the concentration of our hydrogen peroxide, because it's giving you a 30% and a volume, right? Because that's how they sell hydrogen peroxide. And since we had the density, we're good. All right, don't play with 30% hydrogen peroxide. It's very dangerous. All right, then we use hydrogen peroxide time T, first order kinetics, to figure out how much is left. Then we took about how much we started with minus how much remains to figure out how much reacts. We took that, how much reacts, we took it, and we figured out the amount we had, and so we found the moles of how much reacts. And then we did our stoichiometry to get moles of oxygen that forms. And then because we're collecting the gas over water, we had to subtract water's vapor pressure to get the pressure that we have. And then using the ideal gas law, volume, we calculated the volume as 8.75 liters. Again, if you have any questions, don't hesitate to reach out. Otherwise, we'll see you next time, guys. Take care.